Hi everyone. Today we're going to talk about what it's like inside of an atom. If you need to get a hold of me, my email address is on the screen. That's rcrawford@jcpsmail.org. So first off, I want to point out that we know that atoms are incredibly tiny, much, much too small to be seen with even regular microscopes, let alone the human eye. So to understand atoms, we often use models. And you have probably seen some of these models before, but these models also represent how humans' ideas have changed over time. So, if we look, you sometimes still see atoms represented as a solid sphere, like a BB. That is one of the oldest models for an atom. This is a model, this nuclear model, that was from, I believe, the 1960s. And the nuclear model is still one that some of you have seen before. There is also something called a planetary model, and this is a current model of what we believe an atom is like, and we call that the quantum model. So models are really helpful for when we try to understand things that are incredibly tiny or unimaginably big. So to begin with, when we look inside of an atom, we're going to use a model. We're going to use that nuclear model of an atom, and there's two basic regions of an atom. So to begin with, I guess I should just go ahead and say atoms are made from smaller parts. Now, if we were to take a copper atom and divide it into these smaller parts, we would no longer have copper. So we are talking about something called subatomic particles, and subatomic just means it's smaller than an atom. And all atoms are made of subatomic particles. So these subatomic particles really live in one of two regions. So to begin with, let's look at the center region here. So we can see that we have some of these subatomic particles here in the very center of this planetary model, and we have a couple of different kinds. The very center, the tiny inner region at the center of an atom, we call this the nucleus, much like you might call the center of a cell a nucleus. Now, surrounding the nucleus, we can see that we have these other particles that are moving about, and it almost looks like a solar system diagram, like they're orbiting. And that's because really that's what we're looking at. So we call this outer region where these particles are orbiting the nucleus. We call this the cloud. And so the cloud is the large outer region. So it is much, much larger than the nucleus, the large outer region that surrounds the center of an atom. So atoms are made of smaller pieces that we call subatomic particles. And we have two basic regions, the nucleus, the tiny center region, and the cloud, which is the large outer region. Let's take a look at those particles just a tiny bit more. So we have three different types of subatomic particles, and you can see in our model here that we have three different colors. So we have protons, which are shown here in blue. We have neutrons, which are shown here in gray, and we have electrons, which are shown here in red. Let's look at protons first. So first off, notice that protons are found in the nucleus. Protons are tiny particles that have a positive electrical charge. So an electrical charge, think of that as no different than what you might find associated with a battery. You may have noticed in the past that a battery has a positive end and a negative end, and we're going to talk a little bit more about these charges in just a moment. So a proton is a particle that's found in a nucleus, and it has a positive electrical charge. So think of it as like a +1. Also found in the nucleus, we have a type of particle called a neutron. Now, a neutron is about the same size as a proton, and please notice that it has no charge. In other words, it is neutral. It's a neutron. So protons and neutrons are both found inside of the nucleus. Now, the tiny red particle that we see orbiting here in our model, we call that an electron. Electrons have a negative electrical charge. Now, they are found in what we're calling the cloud. Please take a note here that electrons are much smaller than both protons and neutrons. As a matter of fact, electrons are about 2,000 times smaller. So when we look at those particle sizes, electrons are by far the smallest subatomic particle. So three types of subatomic particles. We have protons and neutrons, which are both found in the nucleus, and then we have electrons, which are found orbiting out in the cloud. All right. So when we say that electrons orbit around the nucleus, I want to give you some sort of idea of what we're looking at. We're looking at these really tiny particles that are orbiting very, very far away, but they're also traveling very, very fast. So electrons orbit the nucleus at about 1,300 miles per hour. Now, excuse me, 1,300 miles per second. That's a big difference. So let's imagine that we start here at school, and then we were to go all the way to Albuquerque, New Mexico. So that turns out to be just a little bit over 1,400 miles. So in 1 second, at the speed that it travels around the nucleus, an electron could move from here at school all the way to Albuquerque, New Mexico. And that is most of the way across the United States. So the thing that you need to take away from this is electrons move incredibly fast, very, very fast. One idea about electrical charges, and this is something that you may already know, electrical charges operate a lot like magnetism. Some of you know that you have two ends of a magnet. You have a north pole and a south pole, and magnets can either attract or repel each other. They can either pull on each other or push on each other. So let's take a look at that. So we know that protons have a positive charge and electrons have a negative charge. So when we have two electrical charges that are different from each other, they're opposite from each other, then those particles that have those charges are going to attract. They're going to pull toward each other. Now, if we have particles that have the same charge, whether it's two protons, two positives, or two electrons, two negatives, those are going to push away from each other. Those are actually going to repel each other. As we continue talking about atoms, this idea of attraction and repulsion is going to become more and more important. So I want to give you some sort of idea of the scale inside of an atom. So to do that, the best way that I have seen, the best example I've seen, is if we were to take one atom, which we know is incredibly tiny, but we were to make it very large. We were to make it maybe the size of a football stadium. And at the center of that football stadium, we're going to represent the nucleus. We're going to take something that's about the size of a marble, and we're going to put it right here on the 50-yard line. So here we have the nucleus, which is actually very tiny, very, very tiny, and it's at the very center of our atom, which is represented by our football stadium. Okay, so now let's figure out where this cloud is. So our cloud is going to be the outside edges of this entire football stadium. And remember, our nucleus is made of protons and it's made of neutrons, which are much larger than the electrons, which are going to be orbiting out here. So what that means is we're going to have, at this scale, we're going to have these almost invisible tiny particles that are going to be orbiting out here at the outside edge of our football stadium. That's going to be our cloud with our electrons. And we're going to have in here, we're going to have our nucleus that'll be made up of protons and neutrons, and that's going to be about the size of a marble. And everything in between here, guys, is just going to be empty space. So atoms essentially are nothingness. They're made of almost entirely empty space. Another way to look at this is if we were to take something like one of the world's largest skyscrapers and remove all the empty space from every atom that made up this skyscraper. So we removed all the empty space and we just compacted those protons, those neutrons, and those electrons, and we pushed them right up next to each other. All those atoms, instead of taking up all this space of a skyscraper, would be able to fit inside of a grain of rice. So there's tons of empty space. Atoms are almost entirely made of empty space. So if we're made of atoms, that also means that we're also mostly made of, well, nothingness. You're mostly empty space. Anyhow, that should do us for today. I hope you have a great day, and we'll talk again soon.